Okay, welcome back. You may have already noticed a little mistake I made at the end, and I was rushing to get things in before the 15 minutes were up. So when I was looking at what was happening to x inside the equation, so the first thing that happens to x is I add 40 degrees to it. Okay, so it's x plus 40 degrees, and then I multiply by half or divide by 2. Okay, so when I go in reverse to find my mapping rule, I'm going to multiply by 2 first, and then, of course, subtract 40 degrees. Okay, so how do I do that? So I'm going to have x, multiply it by 2, and then minus 40. So that gives me a mapping rule. Okay, so again, the whole idea behind this was to try and create my sketch. So what I'm going to do, now that I have my mapping rule, I'm going to take key points from my parent function, and I'm going to transform them. So what key points am I going to use? Well, if I take a look at the graph of y equals cosine x over here, the key points we're going to use are the ones that are either on the maximum, on the minimum, or on the axis. So for cosine x, that's 0, 1, 90 degrees 0, 180 degrees negative 1, 270 degrees 0, and 360 degrees 1. So these 5 points are enough to give you an idea of what happens for one cycle. And then from there, it's just a repeating pattern over and over and over again. So these 5 points you need to know. So going back here with these 5 points, I'm going to create a table and figure out where those points go after a mapping. Okay, so there's my table right there. So these are my 5 key points. I'm going to take these points and put them into the mapping rule. So we'll do the first one with you. So 0 degrees I put in here for x. 2 times 0 minus 40 is minus 40 degrees. Put in 1 for y. And I get negative 3 times 1 plus 7, which gives me 4. So, or sorry, 4. So that tells me that 0 degrees 1 transforms to negative 40 degrees 4. And I'm going to trust you guys do the math on your own here just to make sure it works, but try all these other points and you should get these 5 points. So with that in mind, now that we have these 5 points, these 5 points will create the basis for a cycle in the graph. So you're going to take your Cartesian plane, okay, and you're going to put those key points on there. Now this graph is finished, but I'll show you how you can come up with yours. So negative 40 degrees 4 is going to be over here. 140 degrees 7 is here. 320, 10 is up here. 507 and 680 degrees 4. Okay, so once you have these 5 points, you have your basis for a cycle, so you can connect them with a smooth curve that hopefully looks sinusoidal. Okay, and the pattern continues on forever. Again, it's periodic. Okay, so with that in mind, let's try and complete this table now that we have this sketch. So amplitude, axis, period, phase shift, and range. Most of these you can answer just by looking at the graph. So for the range, I'll actually start with that one. The lowest value of my graph is 4. The highest value is 10. So my range is all y values between 4 and 10. For my period, there's 2 ways of going about getting that. So I can get it from the graph. So if I want to isolate one cycle here, I've only drawn one cycle, so it starts here at negative 40 degrees at its minimum and reaches its minimum again over here at 680. So all this is one cycle. Okay, and the length of that cycle is going to be the period. So I start at negative 40, end at 680. That's a distance of 720 degrees. So that's going to be my period. Okay. The other thing you could do if you want to calculate the period is going back here. I said that the period is going to be equal to 360 degrees over k. If you look at the equation that we have, okay, the k value is a half. So I could actually calculate it if I wanted to instead of having to look at the graph, if I find that easier. So I could say that my period is going to be 360 degrees over k, which is 360 degrees over a half. When you divide something by half, it's the same thing as multiplying it by 2, so that gives you 720 degrees. Okay, axis, I can see that from the graph as well. So again, my highest value was 10, my lowest value is 4. Halfway in between 4 and 10 is 7. So that would be my axis right there. The equation would be y equals 7. You have to include the y equals because it's the equation of a horizontal line. Amplitude will be the distance from the axis up to the max or the min. So my maximum is at 10, my axis is at 7. That distance is going to be 3. Okay, and last but not least, the phase shift. Now, this one you really have to get from the equation. It tells you how far the graph has shifted left to right. So if you look at our mapping rule here, you see that everything's being shifted left 40 degrees. And that's case up here, you can sort of see it in here, you have x plus 40. Well, that actually means it's shifting left 40 degrees. So phase shift, left 40. Okay, and you can sort of see that from our points here as well. Start at 0, move left 40. Okay, so that's how we do a graph and get some information from there. Here's another one. This is a transformation of the sine function. I would like you to do the exact same thing, and again, see what we can get from your finished graph. See if you can fill in the chart down here. Okay, so give it a try on your own first. Again, start what you did before. Take some key points, create a mapping rule, try and find the transform points, and then from your graph, try and figure out the answers. Okay, so your mapping rule should look something like this. Now, there's two different ways you can approach the mapping rule. If you did it as is, so you'd have x times 3/4, and then minus 15 degrees inside the function. So if your mapping rule, you're going to have x plus 15 degrees, and then this would be divided by 3/4, which would be multiplying by 4/3. So that would give you a mapping rule like the one you see here, the first one. What is often preferable to do with sinusoidal functions is to actually factor out the k value that's inside here, because we based all of our transformations over here off a version where k was factored out. Okay, you'll see that's x minus p left over in brackets. We do not have that here. We have the 3/4 not factored out. So if we factor that out instead, we're going to have f of x equals -7 sine. So if I take out the 3/4, I'm going to have x minus what? Well, I have to do 15 degrees, and I factored out 3/4. So 15 divided by 3/4, which is the same thing as 15 times 4/3, which gives me 60/3, which is 20. So I'll have x minus 20 degrees, minus 9. And then can create my mapping rule from there. So in this case, I would have x being subtracted by 20 degrees first, before being multiplied by 3/4. Okay, so in reverse, you would have x being divided by 3/4 or multiplied by 4/3, and then adding 20. Now, in terms of, both of them will work in terms of trying to create the graph here. Going forward, I'm going to suggest that we do the one that's factored out. Okay, and I'll explain why once we get towards the end when we're talking about phase shift, but for now, I'm going to suggest that you do the factored out part. Now, it won't affect your points right here, whichever mapping rule you used. So you would take these key points off of the sine function. So again, they're different from the ones that we just used for the cosine function, because the sine graph and cosine function are off by a phase shift. But so you take your key points, they came right off of the graph of y equals sine x right here. Okay, run these through your mapping rule. Again, no matter which one you use should create those 5 image points. You can put them on your graph and create your smooth curve. Now, to get your answers for the chart down here, you can get your range by looking at the graph. So if it's from -16 up to -2, okay, your amplitude, or so let's do the axis first. Axis will be halfway between -16 and 2, or -2, which will be at y equals -9. The amplitude is the distance from the axis to your max or min. That's a distance of 7. And period, 2 ways of calculating it. You could actually read it. You could read it from the graph if you like, or I'm going to calculate it just to show the new way of doing it. 360 degrees divided by k. Okay, and my k was 3/4. Okay, it's 3/4 there or 3/4 there, whether it's factored out or not. So 360 degrees divided by 3/4. You can run that through your calculator or work out the fractions yourself. Okay, and that should give you 480 degrees. Now, and last but not least for this phase shift. Now, the phase shift is actually going to be right 20. Okay, and the best way to get that is to, again, look at the point that was starting at 0, because that's not, the point that's starting at 0 is not going to be affected by horizontal stretch or compression first. So this one has been moved right 20, you can see, because it's moved up 20. Now, one of the reasons I ask you to factor out the 3/4 is now we can actually see the phase shift directly from the equation. In the last one we did, we could see the phase shift is left 40, and you can see that part in the equation. You can't see that in the equation necessarily if you don't have the k value factored out. If you do have the k value factored out, your phase shift is going to be staring at you in the face right from the equation, right 20 degrees. Okay, so going forward, when we try and find a faster way of doing this, looking for a point where the cycle starts, to find that value is a lot easier when the k value is factored out, so that's why I'm going to recommend that you do that going forward. Okay, we're going to talk more about the phase shift in an upcoming lesson and how to find it, but again, if you factor out the k value at this point, you'll get the phase shift directly from the equation. Okay, that's it for today. So again, just introducing yourself to transform versions of sine and cosine, because we haven't done too much of that, and the whole idea of a periodic function, a sinusoidal function, and the different sort of definitions associated with that. So practice using the terminology, practice making some graphs, and coming up you'll eventually see a shorter way of making those graphs without having to necessarily use the mapping rules. Okay, that's it for today. Cheers.